Hello guys, my name is Vishwas and I hope you're doing fine. So today's problem for Geek for Geek is count lucky permutation, which is hard. So I also had hard time to solve this. So I took help from my dearest friend Vikram Rajput. He did help me to solve and to get logic from this. And let's see what did he told and how did we solve this problem. So you are given an array of we are given an array of integer n element of a non-weight undirected graph having n nodes and m edges. Okay, so this is the input given. So the detail of an each edge in the graph if is given to you if it is from tool of list to list. Okay, so it's from list to list. So this is a given you are tasked to find the number of lucky permutation of a given array. So we have to give an output of lucky permutation. Okay, then array permutation is said to be lucky if for every node v of I till this I less than 1 less than I and I less than it should be equal, it's okay, n minus 1 in the array there exists an edge between the node v of I and v of I plus 1 in a given graph. Okay, so let's understand this problem with the example. First see what the problem is asking us to find. So we will be given an array. We have to find every permutation of this. So we will be given an array like this. We have to find every permutation whichever is possible. Then we have to see does each v of I plus v of I which is in array v of I and v of I plus 1 is connected. If it is connected, then if all the nodes, all the array are connected, then we have to say this as a lucky permutation. I hope you understood this question. I will tell you how to solve it with like we will understand more detail with the example here. Let's see example. So we are given here n variables and m equal to 2, which is 2 here graph. So now see what is permutation. We know what we should know what is permutation to solve this problem. To solve this problem, we have a 1, 2, and 3. We have to have every possible array which every possible array which will shift itself. What I'm saying here is 1, 2, and 3. So now we will shift 3 here and 2 here, which will be 1, 3, and 2. And we will shift 2 here, we will shift 2 here and 1 here, it will be 2, 1 and 3. And here we will shift here 3 here and 1 here, and this it will be 1, 3, 1, 2 as well as 2, 3, 1 and 3, 2, 1. So this is permutation. So we have to shift in each and every array to get the permutation. So how many variables we can see? So they say our permutation is equal to the number of factorial. So just say we have 3 here. So what is 3 factorial? So what is the factorial meaning of factorial? We have to multiply 3 into 2 into 1, which will come to 6. So does we have 6 arrays? 1 array, 2 array, 3 array, 4 array, 5 array and 6 array. We do have 6 array. So this is invalid. Permutation. But as the question says here, we have only 3 possible permutation. Why does this question say 3 permutation? Why does it say 3 permutation? Because here this is valid. If 2 is connected to 3 or 3 is connected to 2, it is the same thing. So this is not valid. Not valid means it is not accounted because it is repeating itself. But in this case, 2 is connected to 1 and 1 is connected to 3. This is valid. In this case also, here 3 is connected to 1 and 1 is connected to 2. This is valid. this is also not valid because it gives reverse also. It is just reversing itself. So 3 is connected, 2 is connected to 3, and 3 is connected to 1, which is reversing itself. This is also repeating, this is also repeating. So they are variable. The output we will take here 1, 2 and 3, and 2, 1 and 3, and 3, 1 and 2, which are quite different. The same here, 1, 2 and 3 he took 1, 2, 1 and 3, and 3, 1 and 2. I hope you understand why we are taking only 3 out of 6, because they are repeating itself. That's why we are taking only unique value. I hope you understand. Now we will solve how to get output. To get output, the question says here, this 3 and 1 is connected and 1 is 2 connected. We have to see just it connected here. So here 1 and 2 is connected. Do we have 1 and 2? We do have 1 and 2. Now 2 and 3 is connected. It's saying 2 and 3 is connected. Do we have 2 and 3 here? No, we don't have 2 and 3. So this is an wrong permutation, not a lucky permutation. Now we will check for this guy. Does 2 and 1 is connected? Yes, 1 and 2 is connected, so this is also valid. 1 and 3 is connected. Yes, 1 and 3 is connected here, so this is also valid. Now check for this one. 3 is connected to 1. Yes, 3 is connected to 1, and 1 is connected to. Yes, so this one is also valid. The answer for this will be, how many permutations are lucky here? We had 3 here, and first one went because it was not lucky, because 2 is not connected to 3, but rest 2 are connected. The output for this equation will be 2. We are getting 2 here. We are getting 2. Now to solve this problem, we will understand what we can do here. How can we solve here? We will use a recursive code. Not recursive, we will use DP. We will use a DP here, saying, just assume here is 1, 2 and 3. So what we will do here, we will say 0, 0, 1 will represent 1. 0, 2, sorry, not 2. 0, 1, 0. What will it represent? It will represent 2. Now 1, 0, 0. Oh, and it will represent 3. Let's see this example by using a dry run. So I open this. I know you people like it will be difficult to understand this. So we will use a we will dry run the code, and we will understand more clearly what this DP of bitwise says. So I'm opening for this. We will open a IntelliJ. This is our code. I hope you know this adjacent. I have told you this many times, like we have to connect both the graph here. I think so you have know how to do adjacent. We'll just check for DP because this is a new concept for most of you. So let's understand. So I will say for int, first I will do what I will do here. I will create a long DP which has a new long from n to 1 raised 1 arrow n. What does this mean? 2 raised to n. This is a bitwise problem. So if there are 3, so it will be 2. It will be 2 raised to n. In this case, n is equal to 3. So it will be 2 raised to 3, which is 8. We have till 8 bitwise. So like understand what I am doing here. In this case, what I am doing here, I will iterate to every I will just zoom in to make it more clear. Okay. So in this case, what we are doing here, we will iterate to every this one. We will iterate to every column from 0 till n from every array. Then I will say if dp of 1 of any I, so if say 2 of 0 is equal to 1, so we will place them as a 1. Let's see how what I'm saying here. If I equal to 0, I less than n, I plus plus. Let's see what are the output of the DP. SOT, let's see, and let's say the array value is so you have to connect the both arrays, so we will say array. Okay, I'm telling you what is the what are the numbers in array, what all it is extracted. So this will be the variable the 2 raised to n value. So we say dp of j, because we say j, so we're saying j. Okay, after that we have to say this side. We are connecting this guy, so we will say this. Wait, sorry. Okay. After that we have to say if it what does this does, it will be equal to 1. Let's see if it does equal to 1. So value, let's run it and see what we are getting the solution. Let's see here what the array says. The array 1 is connected to JP of 1. The value is equal to 1. So we are assigning the integer, which is we can assign 0 or 1. So we will assign it has 1. And for second array, which is, so here the array here is 2, which will assign dp of 2. The value will be 1. So for 2 it will be 2 raised to 1. For 0 it will be 2 raised to 0, and for 3 will be 2 raised to 2. So we are making a DP where the value of 1 is assigned to the DP of 1 in bitwise, and DP of 2 is assigned to the DP of value 2 is assigned to the DP of 2 bitwise, it is bitwise, and value 3 is assigned to the bitwise of 4th index. 1 comma first 1 is assigned to DP of 1 comma 1, and for 2 is assigned to 2 comma 2, and for 3 it is assigned 3 comma 4. We will assign them as 1. And if you want to get result here, we just have to say 2 raised to it will be 1 here, so we have to reassign here is 3. So we are getting here 3 value. I hope you understand why we are getting 3 here. So 2 raised to 2 and 2 raised to 1 and 2 raised to 1, we are getting the answer here. So this is 1, this is 2, and this is 3. If there was a 4 here, it will be 4 2 raised to 3, which will be 8. I hope you understood this question. Let's find now adjacent. We know how to do adjacent here. Just we have to iterate to the graph and we have to add +1 +1. Why? We have to get the valid value, right? We have to check if there is a 1 here. So that's why we are iterating to the array, and we have to place that has 1. I hope you understand this question. This is simple very. This was very hard. This was very hard. So I explained by this one. Let's do dry run of this. Now I will do debugging of this dry running. So we will go only for one value, because it will take too much time if I do for every value. We will check for only one value. If you didn't get, you can copy this code and you can put it to IntelliJ and you can say to itself. I will just do for one. So let's do debug here. Now the n, so maximum it can go 2 raised to 3. So we have to iterate down here. So now it can go maximum till 3. Max is 1 and n is equal to 3. So we will start from 1, 3. From this guy we will start from 1, till how many we have to go? Till 1 2 raised to n. So we will go down here. We will go down. So now it will be 0. Now what it will do here? It will check if j is equal to I. Why do we have to use this step? In this step, we don't want to repeat itself. We don't want same repetition here. So that's why we are using this function to see if it is repeating or not. So in this case, it is repeating. So it is false. So it will skip this here. It will check for n equal to 2 now. N equal to 1, sorry. So now it is difference. Now it will check a of j is not equal to a of I. If it is not equal to, it will go further. So it will check here, which is not equal to. Then it will. I have made another this one to check to this one if it is an ith value or not. I have made another function called check, which has n value and ith value. But this n value here, n is mask. Mask means it will from 1 till 7. So it will check when what is I here? It is j. It will go from 0 to 7. So it now here j is 1 and max is 1. And here we have to say n and I 2 raised to n is not equal to 0. If it is equal to 0, then it will skip this, and if it is not, then it is false here. So it is equal to 0 because it is AND operator. In AND operator, whatever we do here, it will be equal to 0. After getting 0, we have to, it is false, so we have to return, we have to skip this method, we have to check for again. For j equal to n is less, j is equal to 2 from I equal to 0. Does it is different? It is different. So we will go down here. It will check. It will check if both are different. It is different. So it will go down here. It will check if it is true or false. It will go and it will say it is false. Again it is false. Then it will go check for another thing. For I equal to 1. Now it will go I equal to 1. It will check again here. If I is equal to 1, so it is not equal to 1. It is true. It will go down. It will check if both are equal. It will not equal. It is true. Then it will go check for true or false boolean tree. It is true here. So then it will go check if that have connection or not by using adjacent. So it will go check here adjacent. Does it has connection? It has connection. So it will go and add +1 here. So after adding this, it will go. It will do from 1 till 7. I hope you and I solve for only 1. So then we can add +1 here. We will go again and again. It will give another output here 2. I hope you understand this problem. So let's learn and see. So this was the code here. This was the code. This was the long DPI. After that, we will we added as 1 whatever we found. We added here 1. After that, we added adjacent here. After this, we added adjacent here, and after that we iterate to the graph, and we whatever the connection we saw, we added 1 here, and this all we saw here. This will iterate to 1 till 7. We have to add ++. It will iterate to 1 till 3, and again 1 till 3. So it will check if j is not equal to 3. Why it is checking? Because no repetition should be there. Here it will check if the value is same. If it is not same, it will go down here. It will check if it's a bit value. It will check if it's a bit value. If it is a bit value, if it is equal to 0, then it will return false. If it is not equal to 0, then it will go down. It will check if this both has connection. If it has connection, it will go and add dp of j here, mask of factorial here, XOR. This is XOR. I hope you understood this question. And after that, we will iterate to every array, and we have to find the answer. We have to add every array here. So our answer will be this is easy. We have to go to iterate, and we have to answer all the dp of the variable. Let's compile and see here. We are getting compiled, and let's submit and see. This is getting submitted. I hope you understand each step. If you want more detailed knowledge in of this graph, I thought you people know. If you don't understand this graph, please do comment. I will surely explain you. So it's basically like there will be board, like we have to, there will be a connection in this, there will be we have to attach to every graph, and if they have connection, we have to just say this one, this much only. This is easy actually. This was very difficult, that's why I used dry run in IntelliJ, and this one also in Python. I hope you got this problem. It was difficult. Thank you, Vikram Rajput, for your help, and I hope you like this video, and do comment if you have any doubt regarding this problem. I will surely help you, and please do subscribe to my channel. 1000 is a target. If you do, it is great help, and thank you for watching. Bye.